In this lecture, we are going to discuss on Coulomb's law and principle of superposition. Now, Coulomb's law, one of the most fundamental laws of physics, and the statement of the law goes like this: the force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Mathematically, this can be written as F is equal to something K into Q dash within absolute value bars divided by R square. Now, where F is the force, so this F is force between these two charges. K is a proportionality constant, which is also expressed as 1 by 4 pi epsilon naught, and its value is equal to 8.9 into 10 to the power 9, and its unit is Newton meter square per Coulomb square. Q dash are the two charges and R is the distance between the charges. Now, when the charges are of like sign, that means if these two charges are either positive or either negative, then the force is repulsive. That means when these two charges are having same sign, suppose both of them are suppose positive or both of them are suppose negative, then the value of this force will be positive, and that kind of force are actually repulsive in nature. And when they are unlike, that means if the charges are unlike, that means one charge is suppose positive and another charge is negative, then in that case this force will be negative, and in that case the force is attractive. That means the negative force between the two charges, or negative electrostatic force between these two charges, actually attractive in nature. Now, this is about Coulomb's law, and one thing is left, coming to these absolute value bars. Why these bars are used? Because we are just considering the absolute value of the product of the charges. That means, as we have said, these charges may be having opposite signs. They may be unlike charges or they may be like charges. But here we are only concerned with the absolute value of the force. That means we are not concerned about here whether the force is positive or negative. Now, with this understanding of Coulomb's law, one question may arise. Because here you can see Coulomb's law gives us a means of how to calculate the electrostatic force between two charges, right? Suppose there is a given charge, and whenever we need to find out the electrostatic force exerted on this charge due to another charge, then Coulomb's law gives us a means to calculate that force quantitatively. Now the question is, if instead of a single charge, there are two or more charges which are actually exerting force on a single charge, on a given single charge, then how to calculate the force? Now, this answer is actually given by principle of superposition of charges. Now, this principle states that when two or more charges exert forces simultaneously on a given charge, the total force experienced by that charge is found to be vector sum of the forces that the various charges would exert individually. That means, suppose there is a single charge and we need to find out the force experienced by that single charge due to two or more charges. Then what we do actually, by using Coulomb's law, we find out the force exerted on this charge by each of those charges, and then we add all those individual forces vectorially so that we can get the resultant force exerted on that single charge. So this is principle of superposition of charges. Thank you.